We usually picture black holes as massive, silent cosmic vacuums that swallow and crush everything in their path into absolute darkness. This intuition fails because it relies entirely on how gravity behaves here on Earth, a straightforward force that pulls objects toward the center of a planet. At the extreme limits of the universe, gravity shatters the rules of space, matter, and time. To understand what actually happens out there in the dark, we have to discard our everyday, earthbound concepts of physical reality. The supermassive black hole at the center of the Perseus galaxy cluster sits submerged in a massive, dense ocean of hot intergalactic gas. The black hole's energy blasts push the surrounding gas away in perfectly spaced rhythmic pressure waves, the exact physical definition of sound. These waves form a B-flat note, pitched 57 octaves beneath the lowest key on a piano. This single object has been holding the deepest, longest note in the universe for millions of years. Black holes act as roaring engines, physically manipulating the environment of their entire galactic neighborhood. This immense power also challenges the assumption that intense gravity simply compresses solid objects into a dense ball. Imagine an astronaut falling feet first toward a black hole's center. Gravity strengthens as an object nears the center. Across a distance of just a few feet, the pull yanking on your boots becomes vastly stronger than the pull on your helmet. This steep gradient stretches your body downward while simultaneously squeezing the sides inward. This process, called spaghettification, creates a physical tension that eventually overcomes the atomic bonds holding your body together. The astronaut's solid physical shape unravels into a continuous, microscopic, single-file stream of atoms flowing into the dark. Extreme gravity unravels the fundamental structure of matter rather than simply compressing it. Along with matter, extreme gravity dismantles the idea of a single, shared, universally ticking timeline. If you park a spacecraft safely above the point of no return, the clocks inside your cabin continue to tick at a perfectly standard pace. But because the black hole is stretching your local time, the distant universe appears to hit fast forward. You would watch billions of years of cosmic history, stars exploding and galaxies colliding, compress into mere moments. This time dilation forces a single event to split into two conflicting, equally true realities. A friend watching from a distant ship would see your movement cross the boundary. Your image hangs frozen and fading on the edge forever. Yet in your own perspective, time feels normal. You sail smoothly and seamlessly straight through the boundary and into the dark. Because relativity grants both perspectives equal scientific validity, the frozen ghost on the horizon and the astronaut sailing through it are both true, conflicting versions of the same event. We have seen gravity break space, matter, and time. But there is one final assumption left, the idea that a black hole is a permanent fixture of the cosmos. Looking closely at the edge of an isolated black hole reveals that it is a leaking vessel. It continuously sheds a faint stream of particles into the void. This invisible leak of energy, called Hawking radiation, slowly drains the black hole's mass. While this process begins slowly, the shrinkage exponentially accelerates as the black hole loses mass. The smaller it gets, the faster it bleeds out its energy. Near the very end of the universe's timeline, the black hole vanishes in one final, dramatic flash of light. The supposedly permanent cosmic trap is actually a countdown. Once that final flash fades, the black hole leaves behind nothing but empty space.